Okay, we're recording again.
Great. Thanks a lot, Paul. Thanks a lot for inviting us to the San Diego JUG. So this talk is all about JSR381 visual recognition for Java, and my colleagues Zoran and Kevin are joining me today for this talk. And I'll give a brief background why we did this, why we created this JSR, this standard API. And then Zoran will jump into the internals and talk about the architecture of the JSR, of an implementation of the JSR, which is actually really interesting. And Kevin will give a really, really cool demo on identifying TIE fighters with our JSR, which is a lot of fun. So let's just dive right into it. And of course, as we dive into it, the cursor key stopped working. Okay. Can you see the next slide?
Now still on the same slide, JSR381.
Okay.
I guess we should have tested that. There you go.
Why it always happens during the presentation. All right, so why JSR381? A little bit of background. So I think most of us here understand the importance of machine learning. It's a huge, huge trend. You know, I don't have to say that for everyone's been learning about machine learning. You know, and 2.5 years ago when I first got into machine learning, you know, it's like all of us in our careers, like you want to pick a wave. You can't learn everything, right? It's impossible to learn everything. You can try, but it's impossible to learn everything. So you pick your waves, right? You see, you know, you're surfing, you're out in the ocean, and you see these waves. Which wave am I going to ride and understand the best? So I saw this nice wave coming, machine learning. I said, that looks really cool. And just like when I first learned Java, the more I learned about machine learning, the more excited I got. It wasn't just like a little invention or a little innovation. It was huge, right? So, and I'm sure you've seen some of Andrew Ng, Professor Ng's talks on machine learning. He's like one of the godfathers of the trend. He talks about it like this is like the next electricity. And after reading about machine learning, learning about it, he's entirely right. This is an important innovation, and not just for developers, not just for Java developers or software developers in general, or even computing. This goes beyond computing. This involves like the human race, the planet. This goes beyond just technology. So this is why I got excited about it. And also with my background, you know, being a musician, I mean, Zoran and I are both musicians. We're both interested in patterns. And machine learning is all about patterns. So this really excited me. So as I started reading about it, you know, there's of course the usual definitions, and I wanted to point this out, and you know, perhaps Zoran can go into just a little more detail later. But you probably will read about, you know, AI and ML and deep learning in the trade press, and some of it, you know, it's more detailed. Some of it, you know, is stuff for us, you know, the tech people, and some of the articles are for the average layperson. But I wanted to sort of just make sure when you hear these terms that this is what they mean. So the umbrella term is AI, and AI, you know, has been around since the mid-50s. And certainly in general, AI has been around since the turn of the century, you know, and we had steam engines and people started talking about robots made from steam engines. So that was sort of an artificial intelligence. So AI is just basically machines that are mimicking intelligent human behavior. You might argue that human behavior is not always intelligent, but that's another thread entirely. So, so that's AI. Machine learning is and we're all Java people here, so machine learning is a subclass of AI. And it's where a machine is learning from experience, from past data. So it's a subclass of AI. And you'll see a lot of articles on machine learning. Deep learning is a subclass of machine learning. And deep learning is what we're talking about. Deep learning is, again, a subclass of machine learning. But since we have the cloud and we have these advanced algorithms using neural networks, specifically, we're talking about deep learning. But in the trade press, you may just hear machine learning. But think of that, whenever you see that, 9 times out of 10, you're going to be talking about deep learning. Now, exactly what it is in a nutshell. So we know that when you learn a foreign language, you could spend years learning a foreign language. You can learn all the rules and the grammar and sentence structure. And if you remember from your basic, back in grammar school, when you kind of outlined a sentence, you learned the rules and you understood the rules. And some people went to school for years and just learned the rules of a language. The alternative is to either go to a country or have someone that knows the language, and you talk to that person and you get corrected and you get corrected again. And then you say something right. And they said, that was exactly right. And you say something wrong. So no, that's wrong. You should be saying this. So over time, you're trained, right? You observe someone who knows the actual data and you follow that. And you learn much faster than spending years learning the rules. So what's on the right is machine learning. And on the left is traditional programming. And when you think about it, the way we've been doing programming for the past 50 plus years, 50, 60 years, has been what's on the left, right? When you come up with an algorithm or designed to solve a problem using Java or any other programming language, think about it. You're designing the algorithm as if you did the work. You're designing the solution as if you did the work, except the machine's going to do it better, faster, more accurately, right? We're now moving in a different direction. We're now having the machine understand, recognize patterns and come up with solutions. So what is the core of ML, the core of machine learning? It's to recognize patterns in the data. And once you see the patterns in the data, you make predictions based upon the past patterns. So that's the core of machine learning. So, but what you tell your boss, when you tell your senior manager, what is machine learning? You tell that person something a little more nuanced. Okay, it's about recognizing patterns in your data. Whether the data is about mortgages or it's about sales, e-commerce sales, whatever the pattern is, you can notice the pattern, and then you can anticipate based upon past behavior. We know what the future is going to be within a certain confidence level, right? So you have similar data, you can sort of guess. And the important thing, this is the important thing for businesses. Now that you sort of have an understanding of what the future might be, you take steps to maximize benefit. And I should say, emphasize ethical business benefit. That's very, very important when you talk about ML and AI, is ethical business benefit. And we'll get into that a little bit later. So he said, this is really cool. I want to learn all about machine learning. And you go find out, like, wow, this is really cool. It's like, this is machine learning. This is an awesome, awesome innovation. But you have to program in Python. So as a Java developer, it's like, wait a minute. Yeah, I think I like Python, but I'm a Java developer. And I have to put things into production, serious production, real production, right? And I'm not really a data scientist. And there's 12 million of us. So how can we get the Java community to play in the machine learning game? So Java needs to be a first-class citizen for machine learning. And I think both Zoran and I, years ago, we came up to the same conclusion. Like, okay, well, we don't want another JavaScript doomsday scenario. And what I mean by that is it's not a dig at JavaScript as a language. Although if I had a few beers, I would go into that with you, but no, we're not going to do that. It's what I meant by doomsday scenario. It's like, let's say I just invented music, right? Just like we have the web in JavaScript. I just invented music, and I'm giving you a clarinet, and I want you to create the world's music with just a clarinet. What would you say? Well, I could do that, and there's some great music, some great clarinet music, but I can't express myself because I'm not a clarinet player. So that's what I mean by doomsday scenario. We can't have one way to express all the world's creativity. And Python is a really good language. It's a great language for data scientists, but there has to be others. And there's 12 million of us Java developers. We don't want Python developers to have all the fun. So we need to play the game too. And people have started to build Java APIs, but there's actually some issues, and I'm sure Zoran will dive into this in a little more detail. There are significant issues. So everybody knows the best way to learn something is to teach it or have someone, talk to someone that knows the topic. So what I did a while ago is that I ran an ML conference when we used to have conferences. We used to have face-to-face conferences. I ran it in a beautiful city of Rome, and I invited people around the world to speak, and great speakers, great speakers. And we had a speaker dinner one night, and we had all speakers except for one speaker. And Humphrey Shell, my colleague, and he missed it because he was running a marathon. So he showed up the second day. His talk was on the second day. So he shows up, all tired from running the marathon. But I felt bad since we had this really great speaker dinner. So I just took Humphrey for a dinner that night, the second night. And we went across the street from the conference at this place called Gran Sasso's restaurant. And it was a great little, Italian bistro. And he was a Java developer, and he had to do ML, and he's 20-year Java developer. So we had two old timers having glasses of wine, really good wine too, at dinner. And we're talking about okay, we have to learn Python, but we have to put this in production. And there's some cool things in Python, but Java doesn't have. So we started talking about what Java needed. So when you get a chance, I have the link down in the bottom right, so you can visit and read this article. So actually, Humphrey that night went and he wrote the notes of our dinner and multiple glasses of wine in this article. So what Java really needed. So we thought we need to promote Java for ML. We can't wait for someone to do it. So this is like what Alan Kay says. If you don't see someone doing it, just invent it yourself. Do something yourself. Take the initiative. So that's what we did. So Zoran and I started going to all these different companies. Even though Python was the language to use for ML, and we asked people, would you be interested in more Java APIs? And unsurprisingly, we had all these companies says, yes, we're interested in this. And we talked to, I had a nice chat with Brian Getz, of course, the architect of Java. And we talked about the future of Java and how it will support ML. And we talked to, of course, Oracle's interested in Google and Twitter, all these companies. We talked to CTOs and senior developers, all these companies. Everybody was interested. So we thought this is wow, okay, everybody's really, really interested. So we started, how do we provide a nice ML API for Java developers? We didn't want to boil the ocean, right? That's your manager will tell you, don't boil the ocean, come up with a deliverable first. So what's a deliverable? Well, we could do visual recognition. And just coincidentally, we just had a meeting just about an hour and a half ago that we're submitting it for the first public release of JSR381 today. So this is a nice day, a nice milestone for the group. So the three of us, Zoran and myself, and Kevin joined us, and Kevin's been a huge contributor, and now in the extra group for 381 has helped out significantly. And the other people who helped out, we've had people from Amazon and from Google, and many of the user groups. We have a lot of people helping us. And this is a really, really good sign. It's not just some small number of developers. These are big companies interested in Java for ML. And one of the big companies, of course, is Amazon. Actually, one of the humongous mega companies is Amazon. And they have an implementation of JSR381 using their deep Java library. And they wrote a really cool article, and they asked us for some input on the article for InfoQ. So you could find that, just look for that title, you'll see it in InfoQ, and it talks about their library and JSR381. So what we want to create, and Zoran will go to detail on the implementation, is that we wanted a Java-friendly API. Not just a C-level API or C-flavored API. And we wanted something that wasn't just visual recognition, but was a generic machine learning foundation. Something that Java developers can use. That you didn't have to be a data scientist. and it provided all the right abstractions, and it felt like Java. It didn't feel like C. So with that, let me turn over to my colleague Zoran, who'll talk about the specific architecture and the implementations of JSR381. Zoran.
Can you please stop sharing? So, okay. Yes. Okay. Okay. Do you see the slides? Do you see the slides? Sorry.
Yes.
Okay. Hi, everybody. I'm Zoran Sevarac. I work at University of Belgrade, teaching AI, and also in a startup DeepNet, building the deep learning platform. So our motivation for creating JSR381 came after we had some experience with the existing Java machine libraries and experienced some issues. We saw some issues with these offerings. Specifically, there are many disparate open source and proprietary machine learning toolkits and imaging libraries, and they all have different sets of algorithms. They use different image classes. Some of them have native dependencies, which really have creates problems with portability and maintaining these libraries. Also, each of them have a different set of APIs, and when you want to switch to another one, you have to learn it from the beginning. And even more of that, they don't share some common abstractions, and they all keep reinventing the same things, like it has been done with collections before the collections API came into the game. And Java is all about that. Also, these APIs seem pretty complex for average Java developer because they're required to understand the low-level details of imaging, or to understand the details of the machine learning algorithms, which most of Java developers don't have. And in addition to that, they all had like C flavor or Python-like flavor. They don't feel like Java. They're not what the Java developers would expect from a Java API. So our main goal when designing this library was to provide Java look and feel for machine learning, what Java developer would expect. And we would like to enable Java developers to use machine learning just using their Java skills. So they don't need to be experts in visual recognition or machine learning domain. Just by getting some classes and looking at their interfaces and signatures, method signatures, they could figure out what to do. Also, our goal is to provide a standard API and in a way unify this development flow for different libraries. And we would really like to see existing machine learning libraries starting to implement this API. So one of the goals was to minimize overhead and make the API very easy to implement by existing machine learning and imaging libraries. And by the way, that's the next phase of our work on this JSR. In like a wider picture, we would like to create a reusable design which can be applied to other domains. So like create a pattern for these, so applying machine learning in other domains, not just visual recognition. And from what we see so far, I think we have succeeded in that. Also, some work is left to be done in future releases. So to come down to practical side of things, what exactly you can do now with this JSR 381 API is basically three types of things. One is to perform classification tasks, then regression tasks, or object detection tasks. classification tasks can be performed on both images and data, tabular data, for example, numeric data. And it comes down to this thing to train, to learn a model to recognize and differentiate different type of things. So you have a set of predefined categories and you want to assign some input object into one of the category based on some historical example data. Then for regression task, it is basically predicting a value or estimating a value. So you feed numeric values into something, for example, a number of users, and you want to estimate the CPU usage or memory usage or the server load. So these are kind of regression tasks. And it is interesting to see how these two basic generic machine learning tasks are combined into the most complex object detection task, which includes both classification and regression. So in the input image, you should be able to identify objects and to recognize individual objects, as you can see on this image. And these types of algorithms combine both classification algorithms and regression algorithms to find position and recognize the objects. At the big picture of the API looks like this, as you see on this slide. What we have created a generic machine learning layer, and we have created a visual recognition layer, which are specialized machine learning algorithms for imaging image data. That way allows us, data architecture allows us to plug different implementations of this generic machine learning layer, or to use different engines. So all you need to do is to have implement this service provider implementation, these subcomponents, and the rest of the system will work without a change. What this architecture gives to application developers is the same standard public API. So if you want at some point to change machine learning algorithms that use new one or use different engine or change anything else, you use the same API. You don't have to change the main application code. You just plug the different engine. I think it is a very important feature because as you mentioned at the beginning, there is a variety of engines, and one of the questions that the developers usually have is which library should I choose, which algorithm should I choose, and how that decision will impact the future development of my system. And this is one of the main questions. We even did a Twitter survey about this. Sometimes, very often, developers are not sure which algorithm to use when. And by having these common abstractions and pluggable implementations, these problems are automatically solved. So to go a bit lower, on lower level, how this looks, how is this implemented? So you can see, I'm not going to go into all details about these classes, it makes no sense, but you can take a look at the documentation and examples that are provided on GitHub. But like a big or general overview, we have this generic machine learning layer in which we have created common abstractions and interfaces for general machine learning tasks. Now, these interfaces are available in many libraries, but they are very specialized, mostly they are very specialized for some specific types of tasks or specific algorithms, or they are too tightly coupled to the user interface, or they have been created with the older Java versions and they don't support modern features or even all the features like generics. They just expect input array and give some integer value as a result or some number as a result, and they are not very readable to Java developers. They're not intuitive. You don't immediately understand what some algorithm does just by looking at its name or the method signature. So we have tried to create these interfaces to be generic as possible, and you can specify types of input and types of the results that they are providing. So from these interface names, you can understand what they do. So for classifiers, we have classifier interface. Now, if you want to have and specify input and return value as a generic type parameter, then for binary classification, that's a type of classifier which returns true or false and probability for true. You just have to specify the input because the result is known. And for multi-class classifier, you can classify objects into several known classes, which can be strings, usually strings, but they can be also Java enums, which are natural choice for categories, right, in Java, or some other Java classes. That would give you a ability to not to work with low-level data structures like arrays, like it's very common in machine learning libraries, but to use higher-level classes like products, users, and you can classify, work with the domain objects with your machine learning algorithms. So three main things are which fall into this category, this common abstractions, is data set. Every machine learning algorithm uses some kind of data set, and there is no standard for data set at the moment, which makes it very hard to compare algorithms to run the different engines on the same data and create some kind of interoperability between them. So this class would be base class for like a collection for machine learning, basic data structure for machine learning. Then classification interface and the regression interfaces. So this is the base. Now, when we get to visual recognition layer, it specializes these classifier algorithms. So if we want to classify images, we have image classifier, which accepts image class as a generic parameter. So you can create an image classifier which works with images on different platforms, for example, buffered image, or on Android with bitmap image, or if you want to use kind of medical images or astronomy images, you can specify some other implementation of these imaging libraries. And to make it easy for end user to implement these interfaces, we have this skeleton implementation, abstract image classifier, which also specifies types of images, it supports, but also specifies the type of machine learning model that it uses under the hood. So if you want to create abstract image classifier, you specify these two things. And at the implementation level, we have like image classifier network, which extends this abstract image classifier, and it implements recognition of buffered images using a convolutional neural network. So these are the three layers and the architecture. And what's important to mention is that end user is not aware of these details. He's not aware of which engine is being used. And thanks to service provider infrastructure that we have used, you can supply a user different implementations, and he just uses the interfaces from this abstraction layer for visual recognition layer. So this is main idea. Now, how do you use something like that? Well, we have created a very simple way to straightforward and expected way for Java developers to build models and to build classifiers using a builder pattern. And by convention, every machine learning algorithm have a static builder method, which returns a builder for that algorithm, and then you can specify different set of properties for that specific algorithm and initiate build method. So the building image classifier for buffered images, okay, so image classifier for buffered images, and using neural networks, because all algorithms follow the naming convention, name of the model under the hood, name of the machine learning model, following the type of task that it is being used for. So it is clear for the name of algorithm what it does, and specify these parameters, and that performs model training. Now we are at the moment working on the detailed documentation about all these settings, because that's something that developers still don't understand, but it will be available. And then if you want to use that classifier, just simply invoke classify method and provide the input image. So this example here shows how to do the hello world example of the MNIST handwritten dataset, handwritten digits classification. So just classify and you get the results as a number and corresponding probability that it is some specific number. So a full example is available on the GitHub on this link. Then this next example shows how to create a classifier for some tabular data. First was for image, but if you want to use like a traditional machine learning using tabular data, it is very similar to the previous, also using the builder pattern, and this time using multi-class classifier, specifying what is the input, what is the type of category string here. And as I said, mentioned in future, we are going to change these float arrays, the just numeric numbers, values to more generic type, like having a Java class here, that would make it even more readable. So when we want to classify something, we again invoke classify method on our classifier and get the results. Also, the reference implementation of this generic of this API is at the moment based on DeepNet's deep learning engine, and it is more information is available on this link. And indeed, DeepNet has released the community edition of their deep learning engine and contributing experience through this JSR as a part of their open source strategy and to support the machine learning for Java initiative. So I now hand it to Kevin. He will show you how this works on his example.
Yes, thanks, Zoran. Gonna make the screen a little bit bigger. So here we have the Star demo. So in this demo, I've been using our GSR, so the visual recognition API, with DeepNet as implementation, and combining it with JavaVix to just give that UI feel. Because it's all visual recognition, I thought it would be nice to have a UI involved into the demo. So yes, so the force. So the use case for this demo is that we have two types of aircrafts, very iconic if you know Star Wars. If you don't know Star Wars, Google is full of it, these images. So on the left side is the TIE Fighter, and on the right side is the Millennium Falcon. So in this image classification use case, we want to determine whether a given image is a TIE Fighter or is a Millennium Falcon. And also for this demo, you can download, you can clone the GitHub repository that we have, and it should work out of the box. So let's first get to training the model. So this is all the code that I use to train the model. So I'm gonna take you step by step what the input really means and what I did compared to the MNIST demo that we have. So we're first gonna start by creating a new builder. And the builder, we're gonna give a input class. In this case, it's a perfect image because all the implementations, like DeepNet's, but also Amazon's implementation, they all require to implement buffered image. So for any implementation that you can that you wish to pick, the input class buffered image is always available. So we're gonna use that as well. Next is the image height and image width. So for some implementations, the data normalization happens up front and happens each time that you give it an image. This is the way of setting it. So this is just the if a image is let's say 60 by 60 pixels instead of 50 by 50 pixels, it's gonna normalize back to just scale it back to 50/50. So so you might get the best results as you can. And the reason why I changed this value because it might be an old value if you're more familiar with machine learning. The reason why I just been experimenting with different values, and because I have a very small data set of approximately 120 images in total, this value was giving me the best results. So it's just a way of experimenting it, and that's why it's set to 50. Next, we have the labels file and training file. So the labels file defines how many classes that you want to train. So you want to create a machine learning model, and that's able to classify, in our case, just two classes, the TIE Fighter and the Millennium Falcon. And then next, the training file is just a combination of your data set that you want to use for training the model, and then assigns the proper label to that single file in your data set. So on how that looks like for DeepNets, on the left side in the blue box, this is the labels.txt. It contains only Millennium Falcon and TIE Fighter. And on the right side in the yellow box, it's for each line, it says the file at the start, and then it's separated by space, and then the label that should be assigned to that file. So DeepNets in our case knows on how to train the model. Next will be the network architecture. So for this input, it's not always mandatory because for Amazon's implementation, they want to enforce their network architecture. So just one, and for DeepNets you can define it by giving it a JSON file. As I was experimenting with the MNIST demo, I just copied the architecture. So this is the neural network architecture used for MNIST, but also for this demo. And the only thing that I changed is the input layer, which is the top, and the output layer. So for the MNIST demo, you have an output width of 10 because 0 to 9. Hold on, the cat is in my neck. And for the input layer, I've set the width and the height to 50. So those are the only changes that I made to the MNIST demo compared to the MNIST demo. So that's also to show you guys on how easy just it is to pick an existing architecture and use that for your own model. Next is the export model. So this is just a parameter to define on where you want to export the model in case you want to export it. Most cases you would like to, because it may consume quite some time to train a model. And at last, we have the training parameters. So first we have the max error, max epochs, and the learning rate. So the max error is just all these values define on how long it would take to train a model and when it would stop training the model. So it's just a way of limiting and speeding up your learning process of the machine learning model. But I will get back to that in a bit. And at last, you will just build the neural net image classifier. And then the training starts. And for DeepNet, you get this as output to your standard output. So here says just that it's training the neural network. And here we have the epochs. So the epochs are really, it's really equivalent to iterations. So each iteration takes 1.5 seconds time, and it shows a bunch of other information. So if so, the way we defined it a couple slides back, we set it to 100. So if it gets to the iteration of 101, it will stop training, and it will say, okay, in the machine learning model is finished training, you can use it. But in our case, it didn't even reach 25. But what happened, and the reason why it stopped training, is the train error. So we in the previous slide we set it to 0.03, and once the train error hits below 0.03, like in the last iteration, it would just stop training and it will say that it's done. And the learning rate is something that you would like to experiment with on how fast you would like to train. So the train accuracy could improve, increase, or decrease majorly by setting the value. It's just a way of experimenting. I also tried training this model for like 1 hour, but it didn't show me any significant improvements when I was training it just 51 seconds. So training it longer doesn't necessarily means that the output of the model is going to be greater than just doing it in much less time. So once we have trained the model, we would like to use it. So let's say if we have a different code base and you just want you import the model file, this is all the code that you would need, and this is not much different from the code in the other slides. The significant difference is that we don't have to define the labels file, again, trainings file, the export model, and the training parameters. The only significant difference is that we're now importing the model instead of exporting it. So that brings us to the actual demo. Yes, so I'm gonna start it up using Maven here. So this is our little UI, and what we're gonna do is gonna go to the top left if you're having a Mac. Here it says open model. So we are gonna grab a pre-trained model that you can also train. So the export of it would be in here. So the trained underscore model .dnet. We're just gonna open it. It's gonna take some time, and it's done. So now we've opened the model. We can also say open image. So that's what we're gonna do. So we're not gonna use the training data, obviously, because that wouldn't be fair. We've got a different, really small test data set. For example, we've got 3 images for the Millennium Falcon, and we got 3 images for the TIE Fighter. So let's just first try the TIE Fighter. So the first image is relatively small. It's only 6 kilobytes. Loads up immediately. I'm gonna press classify, and here's gonna say 77% accuracy for that's being a TIE Fighter. Now let's do that for the second image as well, which is it was really quick, but it's only 3 kilobytes. Gonna classify it, and this one is much lower. And also you can see the image is pretty vague. We don't have that many images with this much darkness, so it's not gonna be quite sure, but it's still It's still not a Millennium Falcon, so that's good. And the last TIE fighter is a little bit bigger file, but still not that big. And here it says that 67% accuracy. Let's do that also for the Millennium Falcon. And all these images are from Google, by the way, so I picked them from Google Image Search. A Millennium Falcon. And this one shows much better results, so 87% accuracy. Let's also do that for the other two images left. So this one also has some noise in the images in the corners, so that's obviously going to reduce the accuracy, but still quite certain that it's a Millennium Falcon, so 66% accuracy. And then the last one, and this one is a relatively big image, so 1.5 meg. The dimensions are also huge. I would recommend actually to scale it down. Just gonna press classify. It takes a few seconds, but then it's gonna say that's 90% accurate. That it's certain that it's a Millennium Falcon. So that brings the end to the demo and on how to use a trained model, but also train your own model. So my suggestion would be just to grab the demo and then start replacing the dataset with your dataset, for example, cats and dogs, which is also implemented by one of our contributors, Nishan. Yeah, just check it out and play with it. That's really the way of learning on how to use our API. I guess back to you, Frank.
Thanks, Kevin. I mean, you might want to show that last slide with those information. Yeah, that's how you get started with the JSR. There's our repo and the getting started document. So it's pretty straightforward. So please, check out the API and let us know what you think. So let us know what you like and what you don't like, so we can tweak it so it's suitable for all Java developers. So
I have some question.
Good. Please.
You guys can hear me okay, right?
Yes.
This is okay. There are a great deal of research going on in the ML and DL space, as you know. And also there are many libraries like TensorFlow, Keras, PyTorch, Theona, I think Apache MXNet. There are quite a few, actually.
Mm-hmm.
The issue is that I was going to ask, they all have their trained models. They not only allow you to do, establish your neural network, but also you can train, eventually save your model to be used in production at some point. Are you able to utilize or load these models? I think you're just currently right now using DeepNets, which is a beta product, I believe, from a commercial company. So you started integrating with that one, I assume, but are you planning to do any other integration with the other big libraries out there? That's the first question.
I think I can let the author of the DeepNets library speak.
Okay, go ahead, please.
Yes, of course. Yes, so we do have plans actually to support other libraries with the VisRec API. The idea is to enable support for different libraries with the same API. So one of the implementations we hope to be TensorFlow implementation. But you are probably aware that Java support for TensorFlow is under development. It's not officially supported. It is being developed by the community, and it has a long way to go. Now we are looking into the best way to support TensorFlow, but having in mind, we are also participating into this group for TensorFlow and Keras API. But all the libraries that you mentioned are mainly Python based. So we want to support them, but when they become ready, and we are going to start in some way to provide some initial implementation to see how it goes. And,
Go ahead, please.
And this one of the rules of the JSR when we started was the idea was also to provide pure Java implementation. So we have this portability, and it is a commercial product, but it has also open source on the GPL with class path exception license. So it
Okay.
is fully open source. You can use to see how it works. And we also, our idea was to identify the things that need to improve and change maybe in Java platform in order to provide more efficient implementation, a more performant implementation for machine learning applications. And one of the things that we are also working with TensorFlow group and DL4J guys is also discussing about the ND array standardization effort. So if there are anybody interested into this like a low level machine data structures and performance, and we have open documents to initiate this kind of specification.
Okay, great, great. And also Apache MXNet, I believe they do have Python, Julia, C++, and pretty much sure Java language bindings too.
Well, actually, MXNet is currently fully supported by DJL implementation. So DJL is from Amazon Java API. So they fully support MXNet at the moment. And they do have TensorFlow support. I don't know if they have stated that anywhere on their site or officially, but they do have. And the PyTorch support is also on its way, but not fully functional at the moment. So at the moment, for JSR381, it supports TensorFlow through DJL.
Thank you so much.
Hey, this is Andreas here. I was just wondering about support for actually two things. One for GPUs, like especially in the demo when you did the classification tasks. I mean, it always took a little bit of time, but I'm sure it's because of the machine and it's high on high load. Are there any performance considerations that you put in the current implementation, or is it the difference between reference implementation and production?
Production implementation, this commercial and proprietary implementation is faster. It has a bit using more threads, better implementation, but for time it will, we are going looking just to figure out the strategy, right? We are going to open source this faster implementation over time. At the moment, only this is this first version, which is a bit behind this proprietary implementation, is open source, but it will be available. And we are looking into the best way to support GPU, because it's not just for VisRec, it's general what is the best way to support GPUs for Java. There was a project, Sumatra, I think, but I don't know, it stopped working on that under OpenJDK, and there are different ways to do it. One is what we are looking into using JCUDA, which looks like a good way. The other way is we are also have DeepNets has collaboration with a group from University of Manchester, which are working on Tornado VM, which provides OpenCL based support for the GPUs and even FPGAs. They have a kind of compiler that optimizes for these specific workloads on the GPUs. And that's something that is going to happen sometime in the future. But it is fully functional now. You cannot do a real-time video recognition, but for a smaller amount of images, even this open and smaller images, even this open source version can do the job.
I mean, you guys have done a great job. It really looks good, and I think it looks much more natural. I'm also wondering about the video. Did you think about how the API would look like for it as well? Or?
Well, to be honest, no, we haven't got to that point. We would like to see, before we get into that, we would like to get the feedback on this base that we have created. And once we are sure that we have solid base and that we are ready to go to more complex use cases, then we are going to look into it. But definitely there is a lot of required demand for that. I mean, maybe one of the main use cases would be for this video recognition. But it will be very similar. The way I see it at this point, you just have to sample frames from videos and you get a lot of images. Now there are additional things that you have to do, but these are algorithms that are basically some variation of convolutional neural networks. And we are, the beauty of this API is that this higher level API that the user will see are not implementation dependent. So that was the goal of creating these abstractions. So you're just as a developer focusing on the task that you want to perform. You say, I want to classify images, I want to detect objects, I want to detect objects in video. And that's what you need to know, which interface to use. And the system should provide the right implementation from you for your types of objects you're using this service provider interface, theoretically.
Thanks. And just one more thing, maybe piggybacking on what Ogun was asking. How close is actually the JSR381 implementation to what the TensorFlow Java API is? Are you working with them in trying to get it aligned, or is it completely different?
We are participating in this, on this mailing list, looking what they are doing, but we are more like higher level API. You know, we are like, if you're familiar with the TensorFlow Estimator API, well, we are something like that. So actual TensorFlow implementation, we are able to use TensorFlow neural network architectures under the hood, you know, and just providing like a API that is more task oriented, you know. So you don't have to think about layers and the low level details how to set up neural network, but just say, okay, I want to use this trained neural network to classify images or something else. So we are on different. So VisRec API will be able to use TensorFlow implementation under the hood.
Yeah, got it. Okay. Thanks. Good job. Thank you.
Thank you. Thank you. Yeah. And thanks for the comment. I really appreciate you guys. That you're saying that you like it and that feels like a Java, what Java developer would expect. I think that was one of our main goals. So and I think along the way, since we're working on this for some time, we have lost, you know, objectivity. So it's good to hear that from the other people.
Okay, are there any other questions in the audience? All right, I see all quiet. Okay, Frank, final wrap up.
You know, I just wanted to thank you, Paul, and thank the San Diego Java user group for inviting us. It's this was fantastic, and as Zoran said, thank you very much for your comments and your questions. This is exactly what we're looking for. We want this to be, as there's a slide says, a Java-friendly ML API, so that all of us are familiar and we know how to use it right away without breaking out our old C++ books or learning Python. So something we're all familiar with. So thank you very much for your comments, and thanks again for inviting us.
Oh, thank you, Frank and Zoran and Kevin for staying up late over there in the EU, and thank you for San Diego for coming to us at lunchtime, which is unusual for us, but hey, it's the new age. I would request, do you have a copy of these slides with activated links? I saw some GitHub references in there to the repos and whatnot. Would we be able to get a copy of that for the community here?
I think we can get you a copy, Paul.
Okay, great. All right, that's it. Thanks, everybody. I will, let's see, stop recording somehow.
Thank you, Paul, and thanks,